Thank you for having me, Reza, and it's nice to be here. I'm going to talk a little about Quora and some machine learning trends and how they relate to us. And I'll talk a little about how we build our developer platform for machine learning internally. Before I start with that, I want to just give some context on our mission. So Quora's mission is to, sorry, one second. OK, great. So Quora's mission is to share and grow the world's knowledge. And we think that the vast majority of knowledge that people would want access to is still not available online. We think that if we can give people the ability to share their knowledge, and we can get a lot more knowledge shared, knowledge that's currently not available, then that's gonna unlock most of the knowledge that people would actually want to get access to. So we're building a platform that connects people who have knowledge with people who want it. And I'll talk a little more about that, but that's a kind of the context, and machine learning is a very, very important part of that. But actually, before I go into machine learning, I want to talk about some technology changes in the past across history and how those have affected the way that people share knowledge. So in the 1400s, the printing press was first developed. And the printing press was this incredible change in the economics of distributing information. So when the printing press came along, suddenly it became financially viable for people to buy books, for average people. And also the economics changed in a way that newspapers were now viable businesses. And the result of all these books and other publications was that humans just had access to much, much more knowledge than they ever had before. And there's all kinds of great downstream consequences for society of that. But one thing I want to just point out here is that the printing press is a little bit different from a newspaper. And so the printing press was this enabling technology that pushed down the cost of distributing information. And then once you have that, you still need someone or some institution to come and build a system on top of that to actually get the full potential of the technology. So next change that I think was sort of incredibly impactful has been the internet. So in the 80s and 90s, the internet came along, and it wasn't really until more recently that internet access became available to everyone on their phones. But if you look at this graph, this is the cost of interconnect bandwidth between ISPs, and it's sort of like since 2000, every 5 years, there's almost a factor of 10 decrease in the price of moving bits around on the internet. And then similarly, this is a graph of the cost of memory and storage over time. And this is a log scale on the y-axis here. So this decline in the cost of storing information has basically meant that we're now at a point where it's effectively free. If what you're storing is language, which is what we're mostly interested in, then we can store all the communication that all humans will ever do over the course of their lives many times over. And so that's not a bottleneck anymore on the ability for people to share knowledge. And so there's this concept called the annihilation of space and time. And it basically means that all cost and friction and latency has been removed from knowledge sharing because of these technologies. And so anyone, it's almost as if you're in the same room as anyone else for the effective purposes of sharing knowledge. And so you could imagine that should cause this huge explosion in knowledge that gets shared. And that has happened. There is much more knowledge getting shared today than ever before. But we think we're still actually very far from a point where people can get access to everything that everyone else knows. And so one way to look at this is in terms of bottlenecks. So once you're on the internet, once data is in a device, it's very cheap to move it to any other device. But we think that most of the knowledge that people would actually want is still not on any device. And for someone to share their knowledge and get it into a device, even if you had, let's say, perfect speech recognition, people can only speak at maybe 150 words a minute. And then on the other side, people listening to speech or people reading, they can only go maybe 150 words a minute if they're listening, or maybe 250 words a minute if they're reading. And so even though the technology has reduced the cost of moving bits around so much, there's still these bottlenecks. And Quora's goal is to use machine learning to help to address these bottlenecks. So on the side of someone who has knowledge to share, we can help them prioritize out of everything they've learned over the course of their life, what are the things that other people want to know the most. So we do that by showing them questions that other people are asking. And then on the side of someone who wants information, we can prioritize the most relevant answers for them, so that we can reuse answers that were maybe written originally for someone else, and so that we can make it so that they get the most valuable knowledge per unit of time that they're going to spend. So maybe just a way to slightly reframe this. There's a pattern where these technologies come along, these really transformative technologies that come along, and then they lead to institutions that get set up around the technology to then help people take full advantage of it so that more knowledge can be shared. And so for the printing press, that was books and newspapers. For the internet, you saw at first things like blogs and forums and a lot of other mechanisms and systems that people set up using the internet. And I think we're going to see a whole new generation of services that are possible because of machine learning, specifically for knowledge sharing. And we see Quora as one of those. So just to make this a little more concrete, here's a specific example. So someone came to Quora and they asked, what's the difference between adding one more layer and increasing the number of neurons in one layer? So they're talking about in a neural network. And we use machine learning. We figure out this is a question about neural networks. And so then we think about who are the people who really know a lot about neural networks. So it turns out Yeshua Bengio, he just won the Turing Award. That was actually after I made this slide. And so when he came to Quora, we know that he knows a lot about neural networks. He probably knows a lot of other things as well, but we know that that's kind of the thing that he can add the most to everyone else by answering. And so we prioritize this question for him. And then he wrote this answer. And it's basically, if you can't read it, it's something like, if you increase depth instead of width, you can represent a certain, more efficiently represent these nonlinear functions. And he didn't have to do much work to write this answer, right? So it's an important point here. He already knew this. He already had done a lot of work over the course of the last 20 years to learn this. And so it was very efficient that we got him to just reuse what he knew and share it with other people. And so that's one specific example. There's I think a lot of people, Quora, because of our focus on personalization, we tend to show people just the content that we think is most relevant to them. And so a lot of people, I think, don't have a sense of the scale we're at. So we're at, right now, 300 million monthly unique visitors who are coming in and getting knowledge from Quora. We're in 17 languages and continuing to add more. That's a graph of total number of answers on Quora. We've been able to continually grow that exponentially over time. And we have been able to do all this with 100 engineers. And so I think relative to other companies that can operate at the scale we're at, we have a much smaller number of people. And that has allowed us to take a slightly different approach to building up some of our infrastructure. And it's pushed us to be extra efficient in some ways that I think are interesting and might be interesting to share with all of you. So we have a lot of different applications of machine learning. We have personalization to route questions. We have feed and digest emails that we send out. We need to rank answers in those. We need to recommend people to follow. We make money through ads, so we have to find the right ads for each user. We send notifications. We need to decide which notifications are worth sending. We do quality control, so there's this whole kind of effective editorial process that happens to separate good answers from bad answers. We don't have too many duplicate questions. We want to know which answers are the best to a given question. And then there's sort of search related questions, helping people navigate around the product. This is just actually a fraction of the number of applications we have. But one thing you might notice is that this is a lot of applications for a small team to manage. And so we've dealt with that by actually investing a lot in building up this platform. So we have so we have over 100 models in production. We have 25 machine learning engineers who build them and are building more. And I think the thing that's maybe unusual here is we've allocated 10 people. So this is 10 out of 100 engineers, so 10% of the whole engineering team to building this machine learning platform. And basically the goal of that platform is just to make the 25 other people as effective as possible and remove any kind of tedious work that they would otherwise have to do. And a lot of this has actually been motivated by my experience in the past as an engineer myself. So at Facebook, I was an engineer before I got into management. And one of the things I worked on was some tools to make other engineers and myself more efficient. And if any of you use Facebook Thrift today, that's something that grew out of this set of tools that I worked on. And I felt like that was something that really made a big impact on the productivity of the team. And because of that personal experience I had, now in the position of being a CEO, it gave me more conviction to be able to make a resource allocation decision like this when the team wanted to invest in this. I think people are always excited to build things like this, but I think leaders often are skeptical of making these longer term investments. So we've been able to make this investment. So here's a bit about what it looks like. So on top you can see the application. So these are things like feed ranking, question routing, follow suggestions, spam detection. There's a lot of those. There's 100 machine learning models in production right now. And on the bottom is the same kind of open source software that everyone uses. So depending on the application, we might want to use TensorFlow or PyTorch or other services. But it turns out if you're just building directly on those, there's a lot of redundant work that needs to go into to building these kind of services. And there's a lot of common properties. So the first thing we built is a feature engineering framework. And the key insight here is that we want to reuse features across many different models. And so the feature engineering framework allows us to just build the features in one centralized place, and then one investment gets made in debugging them, in making them better over time, in keeping them up to date, in maintaining them. And so we can then reuse all that work across all these applications with the feature engineering framework. And it also takes care of computing the features and scaling out the computation that's needed to do that. Next is a training framework. So this takes care of things like scheduling training jobs, deciding when things need to get retrained. We have continuous retraining for a lot of models, managing all of that. That happens with the training framework. And then we have a model serving platform. So this is for inference. If we want to, if you don't have to worry about setting up machines and scalability and managing all of that, then this model serving platform will take care of that for you. I think those are relatively standard. It's probably what you would expect. Some of the other things we've built as part of the platform are a little maybe more specific to our applications. So we have this distributed Bloom filter. A lot of our applications, we want to avoid showing the same content multiple times to people, or we want to just track bits about like who has seen something. So the Bloom filter is a good way to do that efficiently. And we were building this. We had a lot of applications that all needed to use Bloom filters, so we pulled that out and put it into the platform as a service right now. There's an approximate nearest neighbors service, so if you use embeddings and you want to know what other points are nearby in some embedding space, then that's efficient at doing that. And then finally, we have a remote typed storage system. So this is roughly a database or log database, but we have types that we impose on it, so it helps people reuse the data across applications a little bit better. And this investment has been incredible for our productivity, and we're really happy that we made it. We want to keep investing in it going forward. So I want to just talk next a little about where machine learning is headed. So On the left is a graph that probably a lot of you have seen. This is the total amount of computation that's been used in the sort of biggest machine learning models over the last few years. OpenAI published this, and there's a few different conclusions you can draw from this. One is that compute is really important. Another is that it's getting more and more expensive to run the biggest models. And so one of the trends I've been paying attention to personally and as an investor is these machine learning hardware companies. So a whole set of companies are producing these specialized chips. TPUs are already there, but over the next few years, I think we're going to see the cost of compute come way, way down because of these. And that's going to enable bigger models, bigger data sets to train on. I think it's going to really change things relative to where we are right now. But it's not just compute. So algorithms and data are getting better all the time. That's kind of, I think, standard. There's a lot of people will tell you that these are the three things. I think personally that dev velocity of how much a typical engineer can get done in terms of machine learning, I think that's a really important part of these trends that's not always talked about. But a lot of what's constraining the world's ability to use machine learning right now is that it's just difficult to use the tools. And I think that's going to continue to increase over time. And so because of all of these trends, machine learning is going to be an incredibly powerful force. And so as a company, we want to make sure we're aligned with that and we're going to benefit from it. So one particular area that we really care a lot about is personalization. So this is like, how do we route a question to the person who's going to be best in the world to answer it? Or once an answer is written, who are the people who are going to be interested in reading that answer? And over the last few years, we've just seen this continual increase in state-of-the-art ways to do personalization better and better. And that leads to huge gains for us. That's part of what you see. That's part of why we've been able to keep up this exponential growth in answers written. Another trend that I'm really excited about is language modeling. So my understanding is Ilya is going to talk about this later today. But this is this technique where you train a language model on some huge corpus of text, and then you fine-tune it on some smaller data set. And you can use that for any language classifier or anything that you can generate text. Almost any NLP application is benefiting from this. And this looks great now, but I think what's really interesting is over the next few years, as we start to have orders of magnitude more compute to put into things, what is this going to do to the industry? And I think there's a lot of things that are going to get way better. I think this has been seen as a very research-oriented approach so far. Quora, we've actually had a lot of success putting these models into production. So we've had some huge gains over the last 6 months from putting these things in production. I think it's a very important trend to pay attention to. So that's kind of like where things are right now. I think one thought experiment you can run is, as this all goes forward, what's going to happen? And I don't really have a stance on how long it will be to get to human-level AI, but I think it's a useful thought experiment to run of if you did get there, what would you do? And one way you can look at what you might do is just say you had a bunch of people that were employed to do whatever you wanted. And so we can look at how institutions that share knowledge, that hire people, what do they do with them? And so if you imagine the process of a newspaper producing an article, they hire a reporter. The reporter goes out and interviews people who know a lot about the subject that they're covering, and they ask them questions, and then those people answer the questions. But the reporter doesn't just publish a transcript of the questions and the answers. The reporter synthesizes all that information, they cross-check it, they make it more engaging, they maybe hire an illustrator to help. There's an editor comes in and increases the quality even further. And so there's all these other steps involved in sharing knowledge if you have this kind of human-level ability that you would want to do. I think we can see today what a newspaper does with the people they can afford, but with AI, in theory, we should be able to do a lot more because the cost can come down to be a lot lower. And so that should enable this just massive increase in the amount of knowledge that can get shared. So today we think about how do we, when a human user comes to Quora and asks a question, who is the best person to answer it? And that's kind of a personalization problem. In the future, we're going to get to the point where machine learning can generate questions. And I think this is a very realistic possibility, not too far out from where we are today. There's a task of sort of language modeling in terms of figuring out which questions are actually coherent. But there's another task that's figuring out which questions people would actually want to care about. And that could be a prediction problem, or it could be that the software generates a bunch of questions and then people vote on which ones they actually care about the most. And so that's, I think, moving into this world of question synthesis is going to be very important for us. Next is personalization. So today we invest a lot in personalization, but we're very far from where we think we could be. So there's issues like clickbait, or there's things like explore exploit that we're not balancing perfectly. There's giving people context on why something was recommended, helping them get out of being stuck in a local maximum if the system has decided that, if they've drawn a wrong conclusion about what they're interested in. These are all techniques that I think get a lot easier with better machine learning that we're going to see over the next few years. Then there's quality control. So right now, quality control on Quora consists of filtering answers or maybe ranking them at the bottom. But you could imagine quality control for an editor, a human editor, is often about improving the quality of content as opposed to just getting rid of it. So we get there. You could maybe imagine that software helps people make suggestions about ways they could improve their answers. And then finally, right now we do a lot of aggregation. So someone asks a question and we aggregate the answers. We put them in a list. We rank them. But if we could synthesize the answers, that gets to a much higher level of quality than where we are today. So we think that through these kinds of advances, and I'm sure there's also going to be a lot of other advances that we can't even imagine right now, this is going to unlock the potential for people to share much, much more knowledge, and then we'll get all these sort of downstream benefits for society as a result of this. So if this sounds interesting to you, just want to put a quick plug. We're hiring. In particular, relative to other companies, I'd say we're a smaller team, and so there's a little more focus on owning things end to end. But we're not so small that you have to do everything yourself. So we do have good infrastructure to build on. One other thing we do that's a little unique is we have a machine learning transition program. So for anyone who's interested in getting into machine learning, but right now is good at systems or something else, we'll hire you in to work on a mix of that and machine learning, and over time you can develop skills. So we're looking for all kinds of roles. We're in Mountain View. We have a booth outside. Happy to talk to you after this if you have any questions or any interest. So thank you.
Thank you, Adam. The microphones are there, and there, as a reminder. Please, so.
Can you give some more details in the personalization and routing of questions to humans to answer?
Yeah. So you can frame this as a recommender systems problem. We have a lot of data. We know what topics people follow. We know what answers people have written in the past. We have other users who suggest people to answer. We have data about, we can do collaborative filtering, so it's things like other people who have answered these questions, what else did they answer? And we know that if you answered a certain set of questions, then you might be able to answer another set. We have a whole topic ontology, so we can understand that if you answered a question about quantum physics, then maybe a question about some other kind of physics might be good for you as well. We have, language modeling goes into this. So just, you can think of this as like map questions into some space and then see what else is nearby and everything you can learn from that. So there's lots of different features that go into that. And then we look at, our goals are things like how can we increase answers, how can we increase quality answers, how can we increase answers that a lot of people are going to be interested in. And so that's roughly how we have the problem framed today. Does that make sense?
Yeah. Thank you.
Here. Nice talk. So my question is around fake news and in this world of fake news. From Quora, what I see is for a question, I get a few opinions, not necessarily the definitive answer. Are there moves to fact check some of the answers or provide additional information as to how those opinions are formed? And that will be really helpful.
Yeah. So that's something we'd like to do over time. There's a few different ways you can imagine approaching that. One is through votes from other people in the community. And we don't necessarily want to treat every vote equal, right? So other people who have expertise, if they vote on something, then that's a good sign that it's a better answer. There's another thing you do is look at the reputation of the person who wrote the answer. So Yashua Bengio, it kind of didn't matter who voted on his answer. You know that his answer is probably good. There's ways I think we can apply machine learning to this better in the future. You can also imagine other systems that could get set up where people are providing input in a different format than votes. In general, though, I'd say there's a lot of knowledge that's very useful that's not strictly a fact or an opinion. So I think that Wikipedia is a very good place to get facts. And they have a whole fact-checking process that works reasonably well for ensuring fact quality there. There's a lot of other questions that you might ask, like, what's the best machine learning framework? And there's not a factual right answer. The answer is going to depend on the situation. And you just want to hear from people who know what they're talking about and maybe know like who else would vote to support a given answer. And so we focus more on questions like that, actually, as opposed to like strict formal fact-checking.
Thank you.
Right. Thank you very much for a great talk. So I have a question about the machine learning platform that you choose to adopt it at Quora. So as you can, as from the slide, you're building all the frameworks on top of the cloud provider, right? But as you can see that right now, I mean, from the trend, it looks like the cloud provider tends to offer machine learning platform as an integrated solution in the cloud system. So what's your take on that? And do you foresee yourself switching to the all the framework inside the cloud provider as opposed to building on your own?
Yeah, can you tell me like which frameworks you're talking about?
There's one slide that you mentioned about your platform.
Yeah. So that makes sense for our platform, but you're saying the question is like why don't would we switch to an externally provided platform?
So for example, right now multiple cloud providers have some offering on this on their own platform and yeah.
Yeah. Okay. Got it. Okay. Yeah. No, that's a good question, and I heard some of the previous talk, and there's another platform that Databricks is providing. So I'd say the way I think about this is when I think open source and services provided by cloud providers are very good building blocks, and we want to build on top of them as much as possible. But the goal of this platform is to maximize the productivity and reduce the friction of machine learning engineers. And in order to do that, you really want to specialize to the kinds of applications that you have. And so there's a lot of trade-offs involved in building a platform like this that if you're building it in-house for a certain type of product, you can cut a whole set of corners that you don't need to worry about. And then you can go like really deep on other things. This platform, we can reuse our A/B testing system that we use to run experiments, even for things that have nothing to do with machine learning. And so I think getting this end-to-end integration of services and workflows is really important to productivity. And I think that's something that's very hard to do when you're providing something like this as a service. And so you can do it a little bit, and I think that there's value there for sure. If we didn't have the technical capability to build this kind of a platform, then we would definitely want to use one of those. But I think when you're at our scale or you have our kind of capabilities, if you have the kind of people in the company who are excited about building something like this, then I think you can actually get to a much higher level of productivity.
All right. Thank you very much.
Adam again, one more time. Thank you.